Alright guys, so as I talk, I got on here, I got this post-it note with the problems from the book that we're going to do. If I remember correctly, these are the ones that I signed last year. I don't think I'm going to do 60 because I really don't feel like making a big graph or anything. So, yeah. Anyway, you can do 60 if you're feeling it. I'm probably not going to do 60. But there's the page numbers and the problems we're going to do, the ones with those stars 75 and 76. Pretty rough. So as I give you a moment to write those down, let me talk to you for a second. I know it's been a while, but we're going to work through these and we're going to keep moving. I want to try, I think this will be better. First off, we're not going to have a time limit that's going to cut us off. And secondly, I think you guys will be able to see my numbers, letters, and abbreviations. I think you'll be able to see everything else better if that makes sense. Because ultimately that's what I want, is for you all to be able to see what I'm writing and what I'm doing. And for you guys to make out that something was a decimal when we was doing the Zooms with my laptop. The camera on my laptop is not good at all. It has horrible quality. So I want to try this. If this works for you, let me know. With this, you guys need to be following along with this. This is important. This is us moving on with class. I'm not going back to reteach this stuff. Okay? So, with that also, Ms. Thomas has sent out a link for a Iceland survey that really helps us out funding-wise if you guys will take it and do that for us. So please do that. It could have been Ms. Thomas or it could have been your history teacher. But it should be in your live grades. Jump on there and do that for us and just help us out. Alright, so pretty much we did those really hard problems to start with, and now we're getting to book problems and it's going to go from easy and get more difficult, which is why I like using the book problems the way I do. So in this, I just want to start rocking and rolling, so we're going to start with number 56 on here. So you should be on page 82 in your book, and number 56 reads, if the velocity time graph of an object moving on a straight path is a line parallel to the horizontal axis, what can you conclude about its acceleration? So what this is saying is that we have a graph and it is velocity versus time. So here's velocity. I don't know if I can make it fit. And time. And it's saying if its graph was literally just this, so if it was just like a straight line that was parallel to the horizontal, so time, so if it was like this. What can be said about the acceleration here? So the acceleration is what? What can be said about it? And I know you can't find a value for this, but you can conclude something here. You can conclude that acceleration is 0 meters per second squared. The reason behind that is think what acceleration is defined to be. Acceleration is defined to be the change in velocity over change in time. So it's the slope of this. What's the slope of that line? It's 0. There is no change. We're keeping a constant velocity. We're not speeding up and we're not slowing down. So that right there is what we can conclude off 56. If I'm moving too fast in this, it's a video. Feel free to, I don't know, pause it, scrub it back, slow it down, anything like that you need to do. So moving forward to number 57. So number 57. You look at number 57, it says, rank the following objects according to the magnitude of the acceleration from least to greatest. Specifically indicate any ties. So in this case, the key to it is to know that we are going to go from least to greatest. And we're only focused on that magnitude, okay? I can't stress that enough. What do we care about? The magnitude, not the direction. Remember, the magnitude is the number. The positive negative is that direction we talked about. So let's look, and we'll start solving these guys, okay? So let's start here. We're going to start with A. A fallen acorn accelerates from 0.50 meters per second to 10.3 meters per second in 10 seconds. So what I have an initial velocity in the y direction of 0.50 meters per second. I have a final velocity in the y direction of 10.3 meters per second, and I have a change in time of 1 second. Alright, so in this we're just trying to find acceleration. Acceleration is a change in velocity over change in time. So in this case we're looking at the difference of 10.3 meters per second divided by, oh, hold on, sorry. All of this is running too close together. I'm going to do this. Acceleration, the change in velocity over change in time. So that would be final velocity, 10.3 meters per second, minus 0.50 meters per second. All that divided by the change in time, which is just 1 second. I'll punch that in the calculator. To give me 9.8 meters per second squared. So there's the acceleration for A. Alright, now we're going to do B. So let's do B. B has a car accelerating from 20 meters per second squared to rest. So I have an initial velocity in the y direction of 20 meters per second and a final velocity in the x, these are in x direction, sorry, of 0 meters per second. Mr. Hall, how did you get that 0 meters per second? There's not a 0 there because it goes to rest. When it goes to rest, it goes to stop. And the time it took was 1 second. So in this case, the acceleration is equal to the change in velocity over change in time. So we're looking at final velocity, 0 meters per second, minus 20 meters per second. That initial velocity, and all that's divided by time, which is 1.0 seconds. So negative 20 meters per second divided by 1 second will give me negative 20 meters per second squared. So there is B. So we'll go on to C now. Make sure you guys can see C. Hopefully you guys are making this out better. Alright, so on C, a centipede accelerates from 0.40 centimeters per second. So we have an initial velocity in the x direction, 0.40. That's centimeters per second. And they have a final velocity in the x direction because it accelerated to 2.0 centimeters per second. And the change in time is 0.50 seconds. So acceleration, change in velocity over change in time, is, my final was 2.0 meters per second minus 0.40 meters per second divided by change in time, which is 0.50 seconds. These are centimeters, not meters. Sorry. So 2 minus 0.4 divided by 0.5, I get 3.2, and that's centimeters per second squared. Now, all these other ones are in meters, so what I'm going to want to automatically do, I'm going to want to change that to where I can get meters on the top. So I just got to set up a conversion factor. So what I'm going to do is I need meters, so meters on the top. I need centimeters on the bottom, and there's 100 centimeters in a meter. Centimeters cancel, leaves me with meters, and I'll divide that by 100 to get me 0.032 meters per second squared. Okay, that's C. So moving on here, let's do D. D, while being hit, a golf ball accelerates from rest. So I have an initial velocity, I'm just going to say in the x direction, of 0 meters per second to the final velocity from rest to 4.3 meters per second. So 4.3 meters per second. In amount of time, the change in time is 0.40 seconds. So what I'll find is acceleration, change in velocity over change in time, which will be equal to 4.3 meters per second minus 0 meters per second divided by 0.40 seconds. 4.3 divided by 0.4 gives me 10.7, if I get that 7 to look right, 5 meters per second squared. So there is the acceleration for D. So now we're going to go to E. I think E is the last one. It is. So E. A jogger accelerates from 2.0 meters per second. So we initially start 2.0 meters per second, and we get that final, we're accelerating to 1.0 meters per second in an amount of time of 8.3 seconds. So in this, our acceleration, the change in velocity over change in time, which will be equal to final velocity, 1.0 meters per second minus 2.0 meters per second, our initial velocity, and all that is divided by the change in time, which is 8.3 seconds, and that will give me 1.0 divided by 8.3, 0.1, well, it's negatives. Technically it should be negative, 0.1205 meters per second squared. Alright, so now we have all these accelerations, and it's like what I told you before. We do not care at all about that sign. We're just strictly caring about magnitude. Remember that we're going to go from least to greatest. So which one of these is the least? And we're looking just straight up value-wise, number-wise. And when you do that, you should see that C is the lowest. Okay, because 0.0. Nothing even close to that. So we will start with C. C is less than. Now we got to find something. I'm going to mark C, put an X there to let me know I got C. So C's out. So now we're going to go from there. I have 9.8, 20, 0.4, 10.75, 0.12. I want to say that it's E. We're going to go with E. Then C and E are less than, so I'm going to mark over E. So here's my answer that I'm working on. So I can mark E off. And then I got to look at the difference here. So I have a 9.8, a 20, and a 10.75. In that case, I'm going to say we're looking at, it's going to be A, at 9.8. That's gravity. That's less than. So we'll put a mark over at 9.8. I am now left with 20 or 10.7, and lo and behold, the one after that will be D, at 10.75. So there's that, and we're going to do less than. And ultimately, we're only left with one more, so we know that B is the greatest acceleration. Now, I know you're probably looking and saying, Mr. Hall, it doesn't make sense. B is negative 20. Remember what the problem asked us. The problem asked us to find the magnitude and not the overall, okay? So we were just strictly looking magnitude-wise. That's why B is the greatest. It has the greatest number, all right? So there is the answer to 57. For you guys, so that you guys got that there. All right. So let me get me a new page here. So we'll go from 57. We're going to 59. We're just rocking and rolling right along, aren't we? Let's go number 59. So the graph in figure 27 describes the motion of an object moving east along a straight path. Find the acceleration of the object at each of these times. Okay, so here's the thing. We're going to look at that graph below there. It's a velocity versus time, and we're trying to find the acceleration for all of them. So just a good reminder, acceleration is a change in velocity over a change in time. This is where this information is going to come in really handy here. We're pretty much just trying to find the coordinates. We're literally just trying to find points, okay? And we're comparing those final points and the initial points. That's literally what we're looking at here. So, like for example, let's start with A here. Let's do it like this. All right, so for A, all right, the first thing we're going to have to do is we're going to have to find these points. And these points are going to come in velocity and time. So the acceleration is the change in velocity over a change in time, which is equal to final velocity minus initial velocity divided by final time minus initial time. And we're going to keep that initial time because now we're going to find our time segments are not going to be as simple because we're not starting at 0 as always. Now the first one, it's not going to be that bad because we're trying to find between 5 minutes, the first 5 minutes of travel. So what we first start looking at, let's look at that final velocity we end at. So when you look at that graph there, let me see if I can get this in the shot. Give me a second here. So this is what I'm saying is right here on this graph. So right here is this 5 minute mark. Right there is where we end at 5 minutes. So here's velocity. I go over, I'm at 30 minutes. So my final velocity is 30 minutes. So 30 minutes, 30 meters per minute, I'm sorry, meters per minute, minus my initial velocity. Hopefully you can look and see that we started at 0, so it's going to be 0. So 0 meters per minute. All of that is divided by time final. Okay? Where did we finish at? We've set the first 5 minutes of travel, so we stopped at 5 minutes. We started at 0. So 5 minutes minus 0 minutes. Now it worked out this time it would just be 5 minutes, but from here on out when we're working this problem, it's not going to be that simple. So what we will find here, let's see what I did with my calculator. I really calculator, I guess. So what we'll find here, we'll divide that out, subtract it out, divide it out. We'll find that it's 6.0 meters per minute squared. So there is A. So now let's look at B. Now this is where things are going to change for us. If you look at B, I'm not going to waste much time because we're talking between 5 minutes and 10 minutes. If you look at that interval here, so from 10 minutes to 5 minutes, it's a flat line. Because we have that flat line, we know that whenever we're looking at this, acceleration is automatically just 0 meters per minute squared. That's our acceleration because it's not changing. The velocity has not changed at all. So let's look at C. I'm not going to keep bringing the book back and forth. That's taking up a lot of time, and you should have your book open. If you have questions about it, you can ask me later on. Let's look at C, though. When we look at C, we're looking between 10 minutes and 15 minutes. So we're going to find that acceleration is equal to, so 15 and 10 minutes. We have our final velocity. You should get 20 meters per minute minus the initial velocity. So at 10 minutes we were at 30 meters per minute. That's going to be divided by, now this is where that change thing came in place at that I was telling you guys about. We have our final time is 15 minutes, but our initial time is 10 minutes. So you shouldn't have 15 down there, you should have 5. So this will actually end up being negative 10 meters per minute divided by 5 minutes, and that'll give us negative 2.0 meters per minute squared. Now, why is that negative? Why do I have a negative here? The reason I got this negative here, because when you're looking at this change, that has negative. It's a negative slope. We are actually having acceleration in the opposite direction. That's what slowed us down. 20 minus 30 gives you negative 10. That's why we have that negative there. So now let's go to D. The last interval they want us to look at is between 20 minutes and 25 minutes. So in this case, we have acceleration is equal to. So my final velocity at 25 minutes, I am at 0 meters per minute minus sorry, I was looking at the text. We're 0 minus my initial 20 minutes is a velocity of 20 meters per minute. So now we got to look at that time difference. So finals 25 minutes minus 20 minutes. So we'll ultimately end up with 20 meters per minute divided by 5 minutes. And whenever we do that, we'll find our answer to be negative 4.0 meters per minute squared. If I can get my square to look right there. Good deal? So those are the answers to 59. Now on number 60 here, I really just don't feel like doing this graph. They want you to plot a velocity time graph and use the information. Feel free to do that if you want to. I really am not feeling that. I'm not doing number 60. You guys, if you are up to it, go right ahead. Be my guest. I do not care. All right. So the number 61. Number 61, determine the final velocity of a proton that has an initial forward velocity of 2.35 times 10 to the 5th meters per second. So, we're trying to find that final velocity. I'm going to start listing some information out here. I have, we're finding the final, and this is the initial velocity in the x direction of 2.35 times 10 to the 5th meters per second. And then is accelerated uniformly in an electric field at the rate of negative 1.10 times 10 to the 12 meters per second squared. I have an acceleration, negative 1.110 times 10 to the 12th power. And that is meters per second squared. And that is for 1.50 times 10 to the negative 7 seconds. So time is 1.50 times 10 to the negative 7 seconds. That's really quick. So in this case, we are trying to find, the ultimate goal is we want to find final velocity in the x direction. So with this, use the information that's already been given to you, or you can use one of those new formulas if you want to. I think what I'm just going to do is use one of those new formulas to get you used to it. So the final velocity in the x direction is equal to the initial velocity in the x direction plus acceleration times time. So in this case, we can start filling in information. So the final velocity in the x direction, slide up so you can see, sorry. Final velocity in x direction is equal to the initial velocity in x direction, which is 2.35 times 10 to the 5th meters per second. And that's going to be plus acceleration, which I have as negative 1.10 times 10 to the 12th meters per second squared times time, which is 1.50 times 10 to the negative 7 seconds. Whenever I do that, punch this all in a calculator. 5th power plus and what I get is 70,000 meters per second. Set S for seconds. All right. So there is that. There's the answer to 61. So let's jump to problem 62. Let's see. I think I may make it fit. Be close. We'll try to make it fit. So number 62. Marco wants to buy the used sports car with the greatest acceleration. Car A can go from 0 meters per second to 17.9 meters per second in 4 seconds. Car B can accelerate from 0 meters per second to 22.4 meters per second in 3.5 seconds. Car C can go from 0 to 26.8 meters per second in 6.0 seconds. Rank these cars from greatest to least. So we're going, this time we're going to go from greatest to least. Alright, so let's start with car A. The acceleration, I'm not going to break this apart anymore. You guys should be picking up at this point how to break these apart, that formula, and get to this part. So car A accelerates from 0 to 17.9, so my final velocity is 17.9 meters per second. That's final minus the initial is 0 meters per second, divided by the amount of time, which is 4 seconds. So 17.9 divided by 4 equals 4.475 meters per second squared. Okay, so there's A. Let's do B. Acceleration will be equal to, so car B can accelerate from 0 to 22.4, so 22.4 meters per second minus 0 meters per second, and that's in an amount of time of 3.5 seconds, which will be equal to 22.4 divided by 3.5 will be 6.4 meters per second squared. Let's do C. Let's see what car C can get. The acceleration is 26.8 meters per second minus 0 meters per second. And that will be divided by 6.0 seconds. So 26.8 divided by 6 gives me 4.4667 meters per second squared. So here are my 3 accelerations. So now we got to rank this from greatest to least. So the greatest of these clearly is B. So B is greatest. And then we're going to go, what's in the middle? 4.7, 4.6. So A's in the middle. And that leaves C at the bottom. And there's the answer for 62. So you guys can see all of that as well. Okay? So I'm going to stop there because I know it's been a while and I don't want to overwhelm you with a whole bunch of problems. If you guys got questions on that, shoot me a message on Remind and ask me. If not, then you can either expect a Zoom link. If we're not Zooming on Tuesday, then you can expect another video. But you will certainly be hearing from me. Let you guys know, really miss y'all. Can't wait till I get to see you back in person. If y'all need something, holler at me. If you need those problems again, there they are. And as a reminder, I did not do 60. So you guys have a great weekend, and hopefully I'll be hearing from you soon.